Okay, in this video we're going to look at the mathematics of waves and how to represent traveling waves. So in this picture we can see that there is a pulse being generated and the pulse is traveling to the right. So we would like to find a mathematical representation for that. In order to do that, let's look at this simulation here, and I can generate a pulse with this simulation. And there I have a pulse that is traveling to the right. Can generate another one. And let's look at what happens when I draw a coordinate system for this pulse. So let's generate a pulse and pause it. Let's just try one more time. There, I have a pulse. And now let's draw a coordinate system for this pulse. And this is my y-axis here. And I can draw my x-axis. Right, so I have an xy system, and now I can represent this pulse by a function, a mathematic function, right? This blue line here can be represented by a function y is equal to f of x. Now let the pulse travel a little more and see what happens. So I go, so the pulse have moved, right? It have moved. Now it has moved from this point here to this point here. How much has it moved? Well, if it had a velocity v and it took a time t, then this distance here is vt. So now the same function is translated. It's translated by a distance vt. So we can represent this, we can write this mathematically. This one here can be written as f of x minus vt. So this factor here, this factor x minus vt, is what we are going to use to represent traveling functions. So let's look at a mathematical simulation to see this in a little more detail. So I have here a mathematical simulation and I can open here. So what is the function that I'm plotting here? I'm plotting this function. I'm plotting a function that can be written as f of x is equal to 1 over 1 plus x squared. That is this function here that I'm plotting. And let's just have this function travel. We click here on, and you can see now that the pulse is moving to the right as time increases. The time is shown here. This is the time, and as time increases, the the pulse is traveling to the right. So what I'm actually plotting is at every time I'm plotting this function 1 over plus x minus vt squared. So this factor here, when I put it right here, makes this pulse travel. Now let's look at one more thing. Let's look at what happens when, let's see what happens when I change this minus here. Let's change it to a plus. Let's change that to a plus and see what happens. And I can go here and then now I change that to a plus and now the pulse is traveling to the left. So what I'm seeing here is that x minus vt produces a pulse that goes to the right, and x plus vt produces a pulse that goes to the left. Okay, so to summarize, when we have a wave, when we have a wave that can be represented by a function f of x, then the transformation f of x minus vt produces a wave that travels to the right, and the transformation f of x plus vt produces a wave that travels to the left.